Hello, very good morning, dear students. In today's computer aided design session, we'll be having an exercise on analysis of square bar which is axially loaded. Open the ANSYS software at the beginning stage and change the directory to a new folder having ANSYS as the title. Followed by you change the title of the experiment to experiment number 1 and click OK and replot the entire session. Later, you can just follow one by one the steps given in the main menu. Preferences, go to structural analysis, select H method and click OK. Then followed by preprocessor, you can now add, edit, delete the element. You can add beam element having 2 node 188 and click accepted. You can identify that beam 188 is added, close the file. Now since you have completed the elements, you can go for material models. Under material models, you have to identify the type of analysis: structural, linear analysis, elastic member having isotropic property with Young's modulus 2 e power 5 and PRXY 0.3, Poisson's ratio as 0.3. Click OK. Then followed by you are going to define the section for the experiment. The section will be taken from a beam section which is in the standard library. Common subtype will be a square cross section having breadth as 10 units, height as 10 units. And click OK. Now since you have completed the sections, you are moving to the next step of creating the nodes on the active coordinate system. Let us start with first node having at 0, second node at 100 mm, apply it. Third node has 200, apply. Fourth node has 300, at a distance of 300, apply. Click OK. Since you have made 4 nodes, you could see that 4 nodes are available on the graphics area. Now you are going to create elements through the nodes. You can pick up starting from 1 to 2, 2 to 3 and 3 to 4. Let us start with 1 to 2, apply. 2 to 3, apply. 3 to 4 and click OK since you have completed. After node is created, you need to give the analysis type, new analysis, static analysis, click OK. We are going to define the loads and displacement, structural displacement on nodes. At this node number 1, on nodes, select node number 1, and this point we are going to give all the degrees of freedom 0. So all DOFs, select here and then enter 0. Click OK. You could see that all degrees of freedom are 0 in this particular point. You can zoom and then see. After that you can fit the view. This gives a better understanding about the all degrees of freedom. Now we are going to apply the load, force, and select force moment on nodes. At node number 4, you can see that node number 4 is selected here and click OK. And Fx is the direction of the force having a constant value of 1000 units. Click OK. So now you could see that the load is applied along this direction, x direction. I have zoomed it for better understanding, and then I am unzooming it. Now, having applied the load, we have completed the next stage. Moving to the solution stage, solve current LS, click OK. If all boundary conditions and the model is accepted, the solution should be possible. If not, there may be some errors. So now the solution has started and it is done without any error. So solution is done without any error. So now go to General Post Processor. Under General Post Processor, you are going to give the element table, define table. None has been defined. Now we are going to define the table add DOF solution. You can scroll down, you can give the value to be stress, user label for item stress, and you can scroll down this, and then you can select by sequence number LS and put LS1 here, first set, and click OK for this. You could see that the element table is now defined. Close the window, and now after defining the table, you are going to list the table. Under stress, click OK. You can see that save this file as stress. Save this file under the name as stress in the folder ANSYS, which you have created at the beginning stage. Now once this is done, you are going to go for furthermore results, plot the results. Let us see one by one. The stress values are noticed to be 10 Newton per mm square. Now we are going to deformed shape. You can see that the original shape of the object and deformed shape. You can close down the element numbers. Click OK. And you can capture the image. Plot controls capture image. And file save as. You can put formed deformed shape. Save the file. Next one, you can go to contour plot nodal solution. In the DOF, you can select X component displacement. In the deformed plus undeformed model, click OK. You can see that the values are differing from starting from 0 to 0.15. You can capture the image. This is the displacement. So file save as X displacement. Save the file. Now furthermore, to analyze, plot controls, animate, deformed results, DOF solution, click OK. You can see the animation at the node number 1, the displacement is 0. At node number 4, the displacement is at the maximum. So now go to nodal solution. You are going to list the results. Click OK. So at node number 1 it is 0, node number 2 it is 0.5 10 power minus 2, node 3 10 power minus 1, 10 power minus 1.15. So the minimum value is at 1 and maximum value is at. So save this as displacement values. And hold this in the file for later verification if anything is required. Now having done this, you can also close this print solution. There ends the tutorial exercise for you to learn online. In case of any clarifications, please contact me so that I can help you in further understanding the experiment. Thank you.